So as we start to look at triangle congruence proofs, we have some common reasons we're going to see throughout many of the proofs that we're going to do. So we want to go through and kind of just look at the list of them so we recognize when they come up and what to look for and how to use them when they apply to proofs. So the first one we have is reflexive property. And reflexive property is when a side or an angle is shared within both of the triangles we're looking at. And the most common way we see this is something like this. I have a triangle on the left and a triangle on the right. In this case, they both share this side. They're overlapping, so that side is going to be congruent in both triangles. Another way that comes up is if I was looking at this angle right here, and this would be reflexive property with angles. And that's when it's overlapping. Now it's in both triangles. Now you have to be careful. You have to make sure it's the exact same angle that is overlapping. It can actually be confused with our next one, which is vertical angles, which are congruent but not the same angles. So most of the time it's looking at sides. And the beautiful thing about this is it's automatically, we know it's congruent. We don't have to have given information. We can just mark it as congruent. For vertical angles are congruent, we get the vertical angles, like it says, are congruent. If the two lines are intersecting and you have the angles opposite to each other, you say they're congruent. These are just like the reflexive property in that we just kind of automatically get them. If we look at a proof, we know they're automatically congruent and we're going to be able to use them. The next one we have is a mid-segment or a midpoint or a segment bisector. So if I had this labeled with A, B, C, we'll throw D and E on there, and I said that C is a midpoint of AB. If C is the midpoint of AB, it's in the middle of A and B, so that tells us that AC is congruent to BC. It does not tell us that C is in the middle of D and E. And even if we saw something that said like DE is the bisector of AB, it's only talking about AB, so it gets you that congruence. So this one, it has to tell us midpoint. When it does tell us midpoint, our reason is going to be the definition of a midpoint. Now, in relation to an angle, for an angle bisector, it's going to behave, let's try that a little bit better. It's going to behave the same way like a midpoint does, but instead of a segment, we're looking at an angle and it's being bisected. So for this one, let's say we have A, B, C, D, and we have that AD is an angle bisector of angle ABC, or BAC. Now they also may say AD bisects angle BAC, so it may not indicate angle directly, but it's implied. So whenever we have an angle bisector, we get that these two parts are congruent, so we could say that angle BAD is congruent to angle CAD, and that's by the definition of an angle bisector. Next is perpendicular lines. So whenever we get perpendicular lines, we could put in A, B, C, D, and E. We could read this as something like AB is perpendicular to CD. That's using the perpendicular symbol. Now we have a process we're going to look at, and it depends on what we're looking for. So first off, we know that perpendicular lines intersect or form right angles. Then we also know that when you have right angles are congruent. So you have to state, well, they intersect, they form right angles, and once you have right angles are congruent, and then that gives you enough information. It might differ slightly if it's an HL problem. When you're looking at right triangles for HL, you don't exactly need right angles. You can just say that you have right triangles because they contain right angles. So it differs slightly from that. The last one we have is parallel lines. Let's divide this up here. Parallel lines, even though all that work you did in previous chapters with parallel lines, it really comes down to two types: alternate interior angles and corresponding angles. Now, alternate interior will typically look like one of these. So if they give you have parallel lines, We know alternate interior angles are congruent, so that would be these two angles here and these two angles here. So in this type of diagram, you actually get two sets of alternate interior angles to use off the fact of the parallel lines. When it looks more like a parallelogram, and they're kind of like a reflexive side there, it's going to be these two angles. So they form that Z that we're looking at in the pairs. So we then know that those angles are congruent. So if you're reading a proof and you see it mentioned there's parallel lines, you're typically going to have one of these types, and then you get those angle pairs from it. The last one is corresponding angles, and it doesn't come as often as these two, but for corresponding angles, you're saying that these two angles are congruent because they're in the same position if you had parallel lines and a transversal. So these are the common types that we have whenever we're looking at our proofs. What we now need to do is use the given information along with these to get to our triangle congruence. So for this first problem, we're given that L is the midpoint of KN and MP. So in this case, it's actually a midpoint for both of the segments. So we're going to write this over here. L is the midpoint of KN and MP. Now that is, of course, our given. And we're going to label that. I'm going to go double here. There. So let's now state that those segments are congruent. So we're going to say LM is congruent to PL, and that's by the definition of a midpoint. Then the next one is we'll go LK is congruent to LN, and that's also the definition of a midpoint. Now, we have two parts. We needed three parts. So for this one, I'm going to use these angles right here because those are vertical angles, and vertical angles are congruent. So for that, we're going to name it MLK is congruent to angle. So an MLK, we're going to go PLN. Now the last step, because now I have three parts, I'm going to say that triangle MKL is congruent to triangle PNL, and now I need the type of congruence that it is. So I have two sides and an angle. It is the angle between the two sides, so that is side, angle, side. For our next problem, we have that BD bisects angle ABC. That's given. So let's mark that one. So, well, let's get the other givens first. So that's angle BAD is congruent to angle BCD, also given. And you know, while we're here, let's write our triangles that we're solving for at the bottom, because we know that's going to go there. So you could almost take this in every proof and sit the given and the proof and write all of this in. Now we just need to find the rest of the steps. So BAD and BCD are these two angles. I also have that BD bisects ABC, and that's going to be these two angles. So now I need to state that and say that ABD and CBD are congruent. And that's by our definition of angle bisector. So last thing is we need one more piece, and if I look at it, I have a shared side here. So this side, BD, is congruent to BD by reflexive property. And now we need our type of congruence, because we have two angles and a side, and the side is not between the angles. We write this as angle, angle, side. On the back, I'm going to write my givens first. S is the midpoint of QU. I'm also going to say that QR is congruent to ST, and that RS is congruent to TU. So we have three givens here. And that's triangle QRS is congruent to STU. So let's look what I have. So let's mark these parts first. So I got QR, ST, I got RS and TU. Now S is the midpoint of QU, so that tells us that S is in the middle of Q and U. That's also going to give us another congruence, and that's by the definition of a midpoint. And so here I'm going to say that QS is congruent to SU. Now in this case I have three facts. The type of congruence that this is side, side, side. I actually kind of left some space there, but it fits together. Next problem, we have triangle FGH and triangle FJH are right triangles. And then that GH is congruent to HJ. So these are both given. Let's get the easier one out of the way. I do have reflexive property here. So we're going to say that HF is congruent to HF. Reflexive property. And now we look at these angles. So we got right angles here. We have that they're right triangles. If we look at this, it's an angle side side. This is not side angle side. That would be the angles here. So in this case, we're okay having right triangles because we're going to say that this is HL or hypotenuse leg because I have two hypotenuses. That's the shared side, and the legs within the right triangles. So that's HL. So we'd say that FGH is congruent to FJH. Last one, I have that KL and NP are parallel, and KL and NP are also congruent. So let's write those out. KL is parallel to NP. That is a given. And then KL is congruent to NP is also a given. Now what we can add to that is we got some options actually. This one, there's two different routes we could go. There's all three angle pairs are going to match in this problem. So maybe we start with vertical angles and we say that angle KML is congruent to angle PMN. And that's by vertical angles are congruent. Now from here, we actually have two options because of the parallel. We could say that K is congruent to P by alternate interior, or that N is congruent to L by alternate interior. So angle K is congruent to angle P, or angle N is congruent to angle L. Both by alternate interior angles are congruent. And what that does, if I use this vertical angle and one of these, it gives me angle, angle, side. Congruence, angle, angle, side that way. If you said forget the vertical angles and you just named the alternate interior, you'd actually write this final answer different because that would be an angle, side, angle. So just make sure you're labeling it to the correct parts. But just stealing one of the alternate interiors with a vertical, I'm going to say that KML is congruent to PMN, and that's by angle, angle, side.